Water is the lifeblood for crops, especially in regions where rainfall is unpredictable or scarce. Irrigation planning is the process of deciding how and when to water crops. Good irrigation planning means using water efficiently, which benefits both farmers and the environment. This helps farmers grow healthy crops, while conserving water and protecting our precious resources. Without proper planning, irrigation can lead to problems. Overwatering can suffocate plant roots, wasting water and harming soil health. Underwatering stresses plants, reducing yields. By planning carefully, farmers can avoid these pitfalls and ensure their crops get the right amount of water at the right time. Effective irrigation planning starts with understanding the specific water needs of different crops. The choice of irrigation method depends on factors like crop type, land slope, soil characteristics, and budget. Farmers should carefully evaluate the advantages and disadvantages of each method to determine the best way to irrigate. An investment in your farm's irrigation method pays dividends in the long run, economically and environmentally. Here are some practical tips for farmers to consider when planning irrigation water management. Increased crop residue left on the field will reduce the potential for irrigation-induced erosion, increase the infiltration of water into the soil, and reduce evaporation from the soil surface. There is a potential for spray drift and odors when applying agricultural and municipal wastewaters. Time irrigation based on prevailing winds to reduce this potential. In areas of high visibility, consider irrigating at night. The development of detailed topographical soil maps and the identification of environmentally sensitive areas can help with the development of site-specific irrigation plans that better meet crop needs while minimizing adverse environmental impacts. Plan the location of end guns so the overspray will not reach public roads or other unintended locations. Periodic inspection of irrigated areas for the presence of pesticides, animal waste, or the contaminants prior to irrigation can allow these problems to be addressed before they cause a water quality problem. The quality of irrigation water can adversely affect crops and soils. Testing and assessment of irrigation water can help to address adverse impacts of the water on crop quality, plant development, and soil properties such as crusting, pH, permeability, salinity, and structure. Avoid operating heavy equipment on wet soils to minimize soil compaction. To reduce the potential for groundwater contamination, schedule salt leaching events to coincide with low levels of residual soil nutrients and pesticides. Manage water so that it does not drift or come in direct contact with surrounding electrical lines, supplies, devices, controls, or components that could cause loss of electrical power or the creation of an electrical safety hazard to humans or animals. Consider how the interruption of power to irrigation systems from load control, interruptible power schedules, repair and maintenance downtime, and harvest downtime may change the plans for irrigation water management. The use of new technologies for data collection, such as drones, advanced imaging technology, remote sensing technology, yield monitoring, and data logging to calculate water use can lead to more efficient water application. The use of energy-saving technologies, such as low-energy precision application irrigation and the use of alternative energy sources, can result in significant energy savings versus conventional methods. Crop species selection in situations where drought or water deficits are recurrent. NRCS conservationists can help with a conservation plan which assists a participant with implementing their conservation plan by providing site-specific instructions, requirements, plans or specifications for putting conservation practices and enhancements on the land. Conservation planning may involve providing assistance for a single conservation practice or a combination of structural, vegetative, or land management conservation practices, enhancements, and management activities. Prior to initiation of the design and implementation activity, the technical service provider, TSP, will schedule a conference with the participant and the Natural Resources Conservation Service field office staff to ensure an understanding of the participant objectives. The meeting between all parties may take place in person or electronically. Next, NRCS will prepare plans and specifications that describe the requirements for improving the irrigation system, which include, but are not limited to, a plan view showing the layout of the irrigation system, including irrigated areas, planned crops, soils, pipelines, and location, as well as installation information for any moisture sensors, rainfall gauges, or other sensing equipment. Methods to be used to measure or determine the flow rate and the volume of the irrigation applications. Documentation of the scientific method used for scheduling the timing and the amount of irrigation applications. The seasonal or annual planned water application volumes by crop. The management allowable depletion and depth of the managed crop root zone for each crop. An estimate of the irrigation system distribution uniformity based on testing, evaluation, or observation. The specific soil moisture monitoring objectives if soil moisture sensors are used. Indicate how data from the soil moisture sensor locations and depths will be considered to make field-wide irrigation decisions. The specific soil moisture monitoring objectives if soil moisture sensors are used. Indicate how data from the soil moisture sensor locations and depths will be considered to make field-wide irrigation decisions. Information on how to recognize irrigation-induced erosion and how to mitigate it. This will all result in engineering and design and project implementation requirements. Then finally, NRCS will help prepare an operation and maintenance plan for the operator. At a minimum, the following will be included in the O&M plan. Record-keeping documents to be used by the operator to record irrigation water management activities. Requirements for recording each irrigation event, including the amount or depth of water applied, duration of the event, and the date of application. Requirements for recording the methods used for determining the timing and amount of irrigation events. Requirements for recording other pertinent data used to implement the irrigation water management plan. Reference other operation and maintenance plans for the irrigation equipment and water delivery systems. By implementing these practical tips, farmers can optimize their irrigation practices, save water, and improve crop productivity. Irrigation plays a vital role in global food production, but it also puts pressure on our precious freshwater resources. As stewards of the land, farmers have a responsibility to irrigate sustainably, balancing the need to grow crops with the imperative to protect the environment. Efficient irrigation planning is essential for sustainable water management. By using water wisely, we can ensure that there is enough to meet the needs of both agriculture and the environment. It's not just about growing more food, it's about growing food responsibly for generations to come. Together, by embracing innovative technologies, adopting best practices, and working in harmony with nature, we can create a future where agriculture and the environment thrive in balance.